Good evening, class. We are starting section 8.2, the law of sines. Okay. All right, some people just are getting started with us. Okay. So we looked at the first section, right triangle, trigonometry. We did some applications. There are some basic trig identities that we have learned from the past. We really have to remember all of them. So this is the most important page, okay, class, for us to remember. As far as trig is concerned, it contains just about everything we have. And also at the bottom right, I added in essence what we learned in the previous section. I mean, we sort of had known that if you have a right triangle, it follows Pythagorean Theorem, a squared plus b squared equals c squared. And all angles, obviously, all interior angles must add up to 180. So if one of them is 90, the other two add up to 90. And we also discussed the concept of a cofunction angles, okay? So angle of elevation and depression were discussed, okay, and what they mean. And in short, in both cases, we'll compare it to the horizontal line. So in essence, if you're looking down, okay, it makes up an angle of depression. If you're looking up, if an object is above, then we are looking at the angle of elevation in that case. We also discussed the direction and bearing, okay. There are really two types. One of them is when we look at just and compare it with the North Pole, if you will. So we look at the clockwise direction. So I want you to see there are really two ways of approaching this. I will have this a little bit fixed up. So you really have north and then an angle, end of the story. However, the way we've looked at it in this case, we are interested in a slightly different approach, a direction of or bearing. The way we look at it, we look at the closest angle to the north or the south. Okay, so for example, we look at P1 in this case. Okay, as you look at the diagram, P1 is closer to north than it is to the south side. So north, and because it's to the right, east, then we look at the angle in between. So north, 30 degrees east, and the rest follow in the same manner. Okay, you either start with N as north or S as south, and then depending on the side, it's east or west of that. So here's a new section. I want to give you the synopsis of the section, and then we start looking at the sign laws or the law of sines. When we have a different type of triangle known as oblique triangle, okay? Oblique triangle is referring to the type of triangle where the none of the angles is 90 degrees or a right angle, okay? So there are different ways. It could be that all of the angles are less than 90 degrees. They are called acute angles. Or it could be that two of them are acute and one of them is more than 90 degrees, obtuse angles. The sine law says sine A, sine of an angle, the ratio of the sine of the angle to its opposite side, A, is the same as sine of other angle to their opposite sides. So sine A over A, sine B over equals sine C over C, okay? By the way, the reciprocal works also. Let me actually quickly write that for you in case. So if you were, and this is the general form that we write it, but if we were to write this in the following manner. If you wrote this as A over sine A, or B over sine B, C, it should be really lowercase c, I make it a little bit smaller, sine C, that works also, okay class? Needless to say, as always, A plus B plus C, capital A. They must add up to 180 degrees. So this is the synopsis of the section. We're going to look at various cases and we're going to look at the proof of that, okay, to be comfortable with this concept. All right, so the synopsis of the section is discussed. Here's what's going to happen when we deal with different triangles and the concept of solving a triangle. Remember, the concept says solving a triangle means find all the angles, find the sides. That's the meaning of that. So that is really not a big deal and everybody's comfortable with that. Now, in order to solve the triangles, we have many laws. We've seen, of course, the right triangle, but other than that, we need different laws, sine law and cosine law, okay? So between the two of them, we can pretty much solve any triangle if it is solvable. So here's the way mathematicians put this together. The shorthand notations, I want to explore this page a little bit. Okay, the shorthand notation. Number one, ASA. That means angle, side, angle, in that order. Okay, this is case one. Whether you want to call it case one or any other case, it doesn't matter. We are just referring to this as a case one, so it makes it easier to refer back and forth. But who cares? Any case. Case A, case one, case 10. So the point being the angle and the side and the angle. If you look at the top left picture, that is what represents that ASA, okay? Now, the next one is AAS, and I want you to really pay attention to the notation AAS, or they call it SAA. It really makes no difference. It refers to the same thing. We have one side and two angles. So what is the difference between ASA and AAS? When we say ASA, that means we have angle and side and angle. So the side is in between, okay? But the second case, it's not. But nevertheless, we have one side, we have two angles, and it ends up being a unique section, okay? And one unique triangle. We will go through the process. Side SSA, case number two, SSA, side angle, okay? So basically you have two sides and angle, okay? Opposite one of them, and it could result in many different situations, okay? That's why this is referred to as the ambiguous case, because we could have one solution, we could have two solutions, we could have no solutions. Again, this is the synopsis of the section. We will look into this with more details, okay? But understand SSA, okay? and it's at the bottom. We go over that quickly in a moment, but let me just finish all the cases. The third case, SAS, in that order, side, angle, side. You have two sides, okay, like case number 2. However, the angle is in between. It's called the included angle. So I want you to look at the top, diagrams, and look at case number 3 and understand what's the difference between this one and case number 2. That is, there are two sides and the angle in between is given, so this will always work. It gives us a unique solution. Okay. Finally, we have side, 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 SSS. Look at the last case, case number 4. 3 sides are given. First of all, we need a cosine law to solve this. Secondly, this works as long as, and it has one unique solution, okay? As long as one side is smaller than the sum of the other two sides, okay? You'll see what I mean by that. Obviously, if one side, any side, is larger than the sum of the other two, or in fact, if it's equal to the sum of the other two, it fails, okay? So that's the case for number 4. Now, going back to case number 2, as far as some shapes are concerned, and we will make some more sense out of this as we look at more examples, and that is, we are dealing with side, side, and angle. So if you look at the first one on the left, it says the angle is an acute angle. Okay, that means less than 90 degrees. If A is identical to H, we have an answer. Actually, it's a right triangle. Okay. If we have a situation that H, the height, is less than both A as well as B, okay, then one triangle exists. It's a unique solution. If A is no longer acute, the third case is obtuse. That means it's more than, obtuse means between 90 and 180, okay? Larger than 90 degrees. So obtuse is an angle, okay, that is between 90 and 180 degrees, okay. Now, if you have a case like that, and the opposite A, capital A is lowercase a, that really must be the largest side. So if it's larger than B, it works, okay? Now, the next case would be if you're dealing with an acute angle, okay, and A, one side, any side, is less than the height, okay, in this case A is less than H, then it can't make up a triangle. It doesn't work, okay? If A is obtuse, that means larger than 90 degrees, then A must be the largest side. If A is less than or equal to B, that doesn't work either. However, if you have acute angle, A, okay, is in between H and B, then we have two answers. So, again, we look at those cases. Understand what happened here, okay? In case number 2, it's called an ambiguous case because we could have a unique solution, we could have no solutions, or we could have two solutions. So let's see what's coming up. All right, let's start with the sine law. Everybody has seen the sine law. Let's look at the proof. We're going to take a moment to prove that. So this way, at least we've been, exposed to that, because it's a good idea to see it. I I'm not going to ask you to prove that, but it's really helpful if we remember the proof, because if we do, um, everything pretty much comes back to us. So in any event, let's look at a triangle, an oblique triangle ABC, and let's drop a perpendicular becomes the height. Everybody can see the height in red, okay? And so if you look at one of those triangles, okay, you can see that sine A is H over C, okay? I want to make sure that everybody understands what we are referring to here. Okay. So you're looking at this triangle on the left side, okay, class? So sine A is H over the hypotenuse C. And so we can calculate the H by doing the cross product. Okay. Let me use a different color. If we use the right side, now we can calculate sine C as H over A. And again, we do the cross product and we end up with H being A sine C. Well, they are both H, so they must be identical. And so all you have to do, divide both sides by A times C. A times C. Okay, class? On the left side, the C drops. On the right side, the A drops. And so we proved sine A over A equals sine C. Look at the top one, the first one. And the last one we proved, everybody. Okay? So the point being, you can continue on that thoughts. Okay? In fact, it's a good practice that you try to do the rest of them in the same manner. Okay? Now, if you happen to have an obtuse angle, that works out for a simple reason that sine of 180 minus A equals sine A or H over C. I hope everybody remembers that sine is positive in the first as well as the second quadrant. And if you recall, the smaller angle is considered the reference angle. In the second quadrant, you put pi or 180 minus the reference angle. Okay, so those two angles that they add up to 180, they have the same sign. Okay, either way it works. So this is the proof. Again, you're not responsible for that, but if you remember it, it is helpful. So we can move on. What I want to do, I want to look at some examples. Okay. So let's see how we can put this to a good use. Okay, class. So here's the first example we are going to look at. So H is a C sine A, just like before, okay. In other words, this one. Okay. So let's see what happens next. Here's an example, everybody. We want to solve the triangle where A is given as 40 degrees, okay. B is given as 60 degrees, okay. So this is A, okay. This is B, this is C, okay. So I hope you see A, B, C and the opposite sides and all of the above, okay. So it's really not a big deal. So obviously, the fastest and the easiest one to solve would be the third angle. They add up to 180. So I don't think anybody has any problem with that. So we do that. Okay, class? And C becomes 80. So that, I believe, is straightforward. Okay. We are going to move on and take care of the business for the rest of this stuff. Okay. So let's see what happens. Next. Well, sine A over A equals sine B over B equals sine C over C. We have a couple of angles. So we can write the opposite sides. We can write sine 40, the opposite side is 4. Sine 60, the opposite side, I have no idea, it's missing, it's B. We can again use sine 40 over 4 and then sine 80 over C. So I hope you see that we use the portion that is known. Okay, so there are 3 of those, ratios. So whatever is used, whatever is, known, we use them. So in both cases now, cross product, we'll find the missing side. I don't think it's going to be a problem. So, for example, in the case of a B, you have B times sine 40 equals 4 times sine 60, just again as an example. Okay. B sine 40 equals 4 sine 60. So what is missing? B, you have to divide by sine 40. So that's a very simple case. You use a calculator, you go with a couple of decimals. Generally speaking, class, if you see A has 1 decimal, you can, has no decimals, you can add even 1 is fine. But to be on the safe side, go with more. If you put 10 decimals, there is nothing wrong with that. As far as mom is concerned, you're doing my open math, just if they tell you, you just use the appropriate number of decimals. And the other one works out the same way. You do the cross product. C times sine 40 is 4 times sine 80. And then so 4 times sine 80 has to be divided by sine 40 to give you the answer. So I hope you're okay with that. And now we have everything. One of the things that I like to do is to write all of them next to each other. Okay, so for example, okay, I would write right here, for example, B is 539 and C is 6.13. Again, this is when we are doing things on campus, of course, when you do your homework, whatever they ask you to do. If I were taking an exam on campus, then when I'm done with this question, I put all of that together and I'm showing my reader that I got everything that I need to know about this triangle. Okay, so this would be a good, method of doing the work. I think we're ready for the next example. Does that make sense, everybody? Okay. So let's move on. Okay, everybody's done. Everybody's okay with this. Here's the next one. So we have 6.13. You have all the sides, all the angles. Okay, you notice that? And so let's go to the next example. Okay, I think this is pretty straightforward. So what I like to do is actually to pause, okay, and give everybody a couple of minutes. I believe you can do this from the scratch. It's very straightforward. So I'm going to pause the recording, everybody, and you can finish this from A to Z. All right, again, obviously, the easiest one would be the angle, right? Because they add up to 180, so that's easy to find. Now, sine A over A equals sine B over B equals sine C over C, okay? So we can use that. Sine A over A equals sine C over C, okay? And we have just about everything except A that is missing. So you do the cross product, okay, class? You do the cross product. I'm going to go over this fast. You've seen it. You know, you should have no problem with the cross product. And so to find the missing A, it's 5 times sine 35 divided by sine 130, and it gives you the answer. Now, we can use the same thing, sine C over C, which is sine 130 over 5. And this time we find the B, sine 15 over B in the following manner. So we got this 3.74, okay, class? So now you can do the cross product. So 5 times sine 15 divided by sine 130 must be B. Very simple, I think, very straightforward. I honestly can't imagine anybody having difficulties with this. Am I right? So we are hopefully in good shape when it comes to this stuff. Okay, very straightforward, very simple. Okay. So we looked at a couple of examples to see how this thing works. And now we're going to look at, so again, they were simple examples, not a big deal, okay. Having side, okay, and angles, okay, did the job. Having angle, side angle, did the job. Let's move on to a different type of question. All right, so we're going to look at the ambiguous case where we are dealing with side, and angle, okay. So as you can see, H becomes V times sine A, okay. H equals B times sine A. If one side, in this case, the side A, of course, is less than that, then it can't work, okay? it doesn't do the job. Okay. If it's equal to that, okay, it gives you a unique solution. Okay. If H is equal to B sine A. Okay. If A is equal to B sine A, equal to H, that's a unique solution. And we may have two solutions. So there are different cases. We have no solutions, we have one solution, we have, two solutions. So let's see what's going on. And in the case, again, we have discussed this before class. I gave you the synopsis of that, and I'm going over this. So this is the case where we have no solution, or we have two solutions, or we may have precisely one solution. In the case that A is equal to H equals B sine A, the bottom one, there is one solution with a right triangle, okay? And if A is larger than or equal to B, that works too, okay? So larger than B or equal to B. All right. All right, let's look at a couple of examples. Let's start with this case. Okay, everyone. Let's start with this case. And let's go through the process. See what we end up with. So the angle is 40 degrees, and the two sides are 3 and 2. Okay. A is equal to 3, and B is equal to 2, and A equals to 40. Okay. And the way it's given, you just throw in the number somewhere, you try to work it out, okay? It doesn't have to be a perfect triangle. It's a good idea to start with something. All right, so if this is the case, we can write the sine law, okay? Sine of 40 over number 3, sine of B over number 2. I hope everybody can see what's going on here. Sine of 40 degrees over 3, sine of B over 2, right? Everything is known. All you have to do, find sine B, you do the cross product. Again, cross product, I'm assuming everybody's comfortable with that. Will result in 0.43 for sine B. Now, how do we find the answer? We have to find the inverse. So what is B? I want to make sure everybody understands how that thing works. What is B equal to? Sine inverse of 0.43. And so if you calculate that, it gives you 25.4 degrees. However, here's the process that I want you to pay attention to. So this is what it gives you, okay? Let me tell you what else you must do. It gives you one of the angles, and remember what's happening. Sine is positive in the first and the second quadrant. and the angle in both cases would be less than 180. So it's a good one to look at. So what would be another angle having the same sign would be 154.6. Okay, class? So there are two angles that have sine equal to 0.43. However, 154.6 is out. Can anybody tell me why 154.6 is out? Class, take a look at this, what we have done so far. There are two answers for angle B. I want everybody to see that. There are two answers. One of them is 25.4, one of them is 154.6, both of them less than 180. Okay. However, we say 154.6 is not an acceptable answer. Can anybody tell me why?
It's acute.
I'm sorry, one more time.
It's above 90.
There's nothing wrong with that. That becomes obtuse, and that's fine. Above 90 is obtuse. That is not the reason, Joseph. Can anybody tell me why 154.6 is out? In fact, I'm just making something up. That's not an answer, but let's assume, okay, so 154.6 is out. Let's assume it was 130 when you subtract it from 180, and that wouldn't be out. Does that help you see why 154.6 is out? But if, and it's not, if it was, for example, 130, it wouldn't be out, or 135, it wouldn't be out. Can anybody tell me why? Okay, Houston, we got a problem. Well, A is 40, isn't it? If you add 40 to 154.6, it goes beyond 180. So that's why it's out. But if it were, let's say, 130, it wouldn't go. 40 and 130 would be 170. That still works. That's fine. So the reason this one fails is because one angle is known to be 40 degrees. If the sum of that one angle and the second angle is 180 or larger, is out. That's the reason. Is everybody following that? And so now the only one that we have to work with is the first one. So one is 40 degrees, one is 25.4 degrees. You can easily find the third one, 180 minus the sum of the two. So that's easy to find. So you have all the angles. Okay. Now you use sine law. For example, sine of 40 over 3. And by the way, notice, as always, I try to use what is given to me rather than the one that I've calculated. And why is that? Because as we go through the process, we may make a mistake. So stick with what is given to us, class, if you could. Okay? Try to stick with what is given to us rather than what we calculate. All right, so cross product will do the job. It's a simple calculation now, okay? C times sine 40 is 3 times sine 114.6, okay? And the cross product will give us 4.24, okay? So pretty much we're done. We got everything that we wanted, class, okay? So you can look at this and see all the angles, all the sides, and that's it. It's a very simple case. Now, I can't emphasize this enough that you got to pay attention to what? You have to pay attention to the fact that the sum of the two angles will do the job or will not. And in this case, it didn't. So we had only one possibility. I'm going to go to the next case. So what did we have? If you look at the top, I have number 1 in blue. So how many solutions we had? One solution, a unique solution. I'm going to go to the next one, everybody. All right. Now we want to solve this triangle, okay? And the sides are given as 6 and 8. And obviously we can use the sine law, okay? Sine of 35 degrees over 6 is sine of b over 8, okay? Really, there are different ways of writing this. It doesn't come out. This ends up being 1 or 2. You can just draw something if you want, class. Let me just draw something, and at the very least, I'll show you and I erase it so you can throw something in. What I have is by no means to scale, okay? So let's say this is 35 degrees, okay? And A and B are 6 and 8. Okay, so you can say on a 6, this is not to scale, class, as an example, 6 and 8, okay? Or you can write 8 and 6, okay, just the way it's given. So the angle is 35 degrees and the sides are 6 and 8. And however you put that, it works out as long as, you know, you are consistent. So with that being the case, the cross product will do the job, okay? And sine B becomes 0.76. Sine B becomes 0.76. All right, remember how we find B. Now, let me write it here for you. B is what? B is sine inverse of 0.76. Okay, and so if that is the case, what do we get? When we use sine inverse of 0.76, we get 49.9 degrees using a calculator. This is not a common arc. If we subtract this from 180, we get 130.1 degrees. We did exactly the same thing in the previous page. However, what happened in the previous page? This is what I want you to pay attention to. In the previous page, we had to add those two and observe because one angle was given, right, class? So we knew one of them was 35 degrees. In the previous case, of course, if you remember, in the previous case, one of them was 40 degrees. So with this second one, which was 150 something, it went over 180 and it wouldn't work. But now 35 and 130.1, they add up to 165.1. The sum is less than 180, so that works. And that's why we go through the process and it results in two triangles. Okay. Now, in this case, 49.9 degrees, we have something like that. Okay, class? Again, I couldn't show you the graph that, you know, we had to until we figured it out. Okay. So if you look at this one, when we subtract the sum of 35 degrees and 49.9 degrees, we get 95.1 degrees. Okay, so we have all the angles, class. So again, one angle was 35 degrees. One is 49.9. We finish the job by finding the third one. So I don't need that anymore. I just wanted to show you. And so sine 35 over 6, okay, is sine 95.1 over C1, let's say. And we end up with 10.42 as the answer for the third case, the missing side. But remember, the missing side could be this little one, if you will. This is C1, I want you to see that. Or it could be the large one. And why is that? Because the way you put number 6 can go to the right and create this top angle of 130.1 degrees, or it can go to the left and create this top angle of 49.9 degrees. Okay. I'm talking about, my apologies, I'm talking about these two angles, okay? Either this one or the other one. Okay, so with that being the case, let's look at the next case. We are subtracting 35 degrees. Okay, I'm sorry, class. Sorry, class. I don't know. You probably heard my son. That's life. What can I tell you? Yeah.
The inverse of sine of 0.76 that you show up there for the B, is that what the 49.9 degrees is supposed to be?
Yeah, it's not.
I get 49.5.
49.5, okay. All right, we can look at it later on to see, you know, it's 40, so you get, let me see, 49.5. We can look at it, could be. So if that is the case, this is a little bit off, okay? 49.5. If that is the case, then we get 130.5 instead of 130.1. I will look at it later on, but the process is very straightforward. I thought it was 49.9. I can look at it in a moment.
Yeah, I just wanted to make sure I was understanding how we got the 49.9. That's all.
Yeah, that's 0.7. Okay, what we can do, we can look at this one more time at the end. I will use a calculator also to check it out and see. Most likely you are correct. We take it from there. So the point of this, example is that we ended up with two answers. If the answers are off by a little bit, don't worry about that. Of course, you do a better job, okay? And thanks, Laura. Definitely check and recheck. So now the second one, sine 35 over 6 again, sine 14.9 over c sub 2. Cross product will give us 2.69. If one of the numbers is wrong, then the rest of them may be off also a little bit. And so this is what we end up with. There are two possibilities, okay? We could have this one, if you will. Okay, let's just use a different color here. Let's use the green one. We could have this one class. I'm doing the green one. Okay, and that's or this one is a different color, or we could have this one. Okay. The point being, we do get two triangles, okay, class? Now, I'm going to look at that in a moment. And in fact, we're going to take a break. While we take a break, during the break, please, why don't we do that? Let everybody have a chance to look at the calculations and see whether the calculation is decent or off. If it's off, we can change it, obviously. Sounds good? Everybody okay with that? And by the way, thank you so much for looking into that calculation, okay? All right, so why don't we start at 7:10? Would that work for everybody?
Okay.
I'm gonna pause the recording. All right, what we want to discuss is why the numbers were off. And if you recall, I told you, you really want to keep up with the decimals. And I did the same mistake here. This one, I want you to look at it and calculate it. This one, everybody. Use 8. Make sure your calculator is in degrees. 8 times sine of 35 degrees divided by 6. And so what you get is 0.7648. Okay, 0.7648. Now, if you look at the sine inverse for that, is 49.9 degrees. Okay, class? In fact, those of you who have a calculator, you can quickly check that. So it's really using, let's say this one, sine inverse of 0.765. And that makes a huge difference, class, okay? When I say huge, remember it was 49.5 versus 49.9. And that's why it was a mistake. Is everybody following that?
Yes.
So you can check it out and see, how it really changes the result. One of the things you want to do when you do your homework or your exam, do not do the rounding until the last moment. Okay, I should have shown you that instead of 0.76 is really 0.7648. And that's why we get 49.9. And that is extremely important that we pay attention to. Okay, class? So do not do the rounding in between when you want to show your work. Maybe towards the end you can, but it's a good practice to carry on tons of decimals. I'm going to go to the next example. I'm assuming we are okay with this. So here's the next one, class. All right. By the way, just to refresh your memory about the previous page, understand that A was 35 degrees and lowercase a was 6. And that's why we had 35 degrees opposite 6. Maybe I should have mentioned that. Okay, so when you do the drawing, when you put something together, you want to pay attention to that, okay? And so over here, what you want to pay attention to is that capital C and lowercase c, they go together. In other words, the side opposite the C equals 50 degrees is given as 1. That's extremely important for everybody to see. Okay, class? Everybody can see what we are doing here, class? By the way, if somebody keep an eye on the chat for us in case there's a question. I just noticed there was a question. Did the live stream freeze? Anybody had that? Devin, is that what happened? You're okay with that?
It's just before our break, it looked like it had frozen, so that's why.
Okay. So we are good to go right now. Okay. All right. Thanks. Just let me know if you be kind enough, generally speaking, to keep an eye on the chat and let me know, class, if something comes up. In any event, so sine A over 2, sine C or 50 over 1, and we do the cross product. Sine A times 1 is sine A, 2 times sine 50, and we end up with 153, 1.53. There is no triangle. This doesn't work. Why is that, class? Can anybody tell me how we know this is not going to work? Anyone? How do we know this is not going to work? Right here. Anybody? Well, can sine be larger than 1? No.
No.
That's why it fails. So as we go through the process, sine is between 0 and 1. It can give us 1 solution or 2 solutions. Sine is larger than 1, no solutions. Actually, that's a very, fast, question to do. You notice there is no solution. So the bottom line is it's not working out, okay? C is way too small. That's the idea behind that, okay? If you were to graph it, that's what is going to happen, okay? All right, we're going to move on to the next example. All right, again, more applications. Could somebody read this question, please?
A surveyor takes 2 sightings of the peak of a mountain at a distance 900 meters apart on a direct line to the mountain. The observations are at angles of elevation of 47 degrees and 35 degrees respectively. If the transit is 2 meters high, what is the height of the mountain?
Thank you so much. Everybody remembers the concept of a transit. It's just some equipment. Everybody remembers questions about applications such as surveyor, and it's really applicable. And I hope you find this, interesting, again. So we are interested in calculating the height of a mountain, and there is a way to do that. Imagine. So let's see what happens as far as finding the answer. First, let's write everything that we have, okay? Now on the diagram that is easy to read, okay? So pretty much the same thing here, okay? We are interested in calculating the height H of the mountain, okay? And the transit is 2 meters high, okay? That's why we have that 2. And then we've done 2 observations, one at a 47-degree angle, one at a 35-degree angle, okay? So it gives us 2 triangles, okay? And eventually we want to get to H, remember that, okay? And in order to get to H, you can ignore it. All we have to do, calculate B, whatever the value of B is, then we add 2. Does that make sense? So what is the process? We are hoping to find B. Okay, class? We are hoping to find B. So that is what we are looking for. Okay, so we are looking for B. So to find B, okay, either we find the hypotenuse for the smaller right triangle, which has a 47 degrees, or the larger one, which has a 35 degrees. So it's probably easier to find the lowercase c, okay, and then we have 35 degrees, okay. If we could find lowercase c, everybody can see the lowercase c, okay. We're talking about the triangle that has a 35-degree angle on one side. We then can find B by using the sign. So let's see how we do that. Number one, we have 47 degrees here. Everybody can see the 47 degrees, right? Let me use a different color here. So if this is 47 degrees, okay, everybody can see the 47 degrees. Then it's easy to find the angle C because they add up to 180. So the very first thing, we can find this angle to be 133 degrees. That sounds good? That's an easy calculation. That's an easy calculation. And so now we have all the angles for that oblique triangle, okay? And by that, I mean we are looking at this one, class. We have all the angles, 35 degrees, 133 degrees, add them up, subtract from 180, and you can find A to be 12 degrees. That sounds good? So we found A, we found all the angles. We have one side, 900 meters. That's opposite the A angle. Lowercase c is opposite the C angle. That's the sine law we're going to use, and we're going to find the lowercase c using the cross product. Okay, so sine 12 degrees times c equals 900 times sine 133. So 900 times sine 133 divided by sine of 12 is the answer. And you do it with a bunch of decimals, okay? You do it with a bunch of decimals, class. So lowercase c is found. Now, if you look at the big picture, the big triangle, okay, you see that sine of 35 degrees is B over C, where C is just found, right? C is just found. Replace the C and B is the cross product. Okay, so B is 3,165.86 times sine of 35 5 degrees, and 1815.86 or 1816, and the proper units, okay? Because the transit was 2 meters high, everything is in meters. So you approximate it or not, it's not a big deal. Now, what is the height of the mountain? We need to add 2. We need to add 2. And again, it is okay, to go to the nearest ones because it is an approximation. Okay, class? It is an approximation, so it's close. Okay. Applications, I hope you find them interesting. We are going to move on, everybody. Any questions? Everybody okay with this?
Yes.
Perfect. All right, we are ready to move on and go to the next one, everybody. So here's the next one. All right. Could somebody be kind enough to read the question for us, please?
Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. A ship at sea sends an SOS call that is received by each station. The call to Station Zulu indicates that the bearing of the ship from Zulu is north 40 degrees east. The call to Station X-Ray indicates that the bearing of the ship from X-Ray north 30 degrees west. From far, A, how far is each station from the ship? B, if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship?
Thank you so much, Joseph. This is great. Okay. I hope you see, again, fascinating applications of this stuff class, okay? So there's a lot of applications here, and I hope you appreciate the beauty of math and trigonometry. All right, first and foremost, all angles are known because we know 2 of them, 60 and 50, and the missing angle C is just add them up to 180, right? So that is an easy calculation. So we have all the angles. Now class, if we have all the angles and we have one side 120 miles, so we have this side to be 120 miles, which means what? We can find the missing sides. It's a very easy calculation using the sine law. Okay, so we have lowercase c, 120 miles. Okay, so c, lowercase c, is 120 miles. Lowercase a and b can be found by using the sine law. For example, we could say sine of 50 degrees, that's opposite lowercase a, okay, that is equal to sine of 60 degrees over b. That sine of c, which we just found it to be 70 degrees over 120. Then what do? You put these two together and you find the b. You put this one and this one together and you find the a. So to find the a is 120 times sine 50 over sine 70. And that means X-ray. To find the b, that's 120 times sine 60 over sine 70, and that means Zulu. Now, we answered part A. We are going to answer part B in a moment. Before we do that, is everybody clear what happened here? Is everybody okay with this? Okay. Now, if a helicopter capable of flying 200 miles per hour is dispatched from the nearest station to the ship, how long will it take to reach the ship? Well, which one is closest? X-ray or Zulu? Clearly, X-ray is closer, right? Because it's smaller, 97.8 miles. So how long does it take? It takes 97.82 miles divided by 200 miles per hour. Remember that D equals RT, okay? In this case, the distance is equal to A. The distance is equal to A. So you divide 97.82 by 200, it gives you 0.49 hours. And that's close to 30 minutes. So you multiply this one, whatever the answer is, you multiply it by 60 to give you roughly how many minutes. Do you have to change it? If you haven't been asked to do so, you can keep it. But if it was 30 minutes, that would be, if it was half an hour, that would be fine. But because it's 0.49, perhaps we want to make it into minutes. But it's, I hope, clear. Sounds good? Everybody okay with that? Okay. We're going to go to the next example. I want to make sure there is no question and we are okay with this, okay? Okay. Could somebody read this question for us, please?
The highest bridge in the world is the bridge over the Royal Gorge of the Arkansas River in Colorado. Sightings to the same point at water level directly under the bridge are taken from each side of the 880-foot long bridge as indicated in the figure. How is the bridge? How high is the bridge?
Thank you so much, Mercedes. I appreciate that. Okay, I think now you have enough practice. You can do this on your own. I'm going to pause the recording, give everybody a couple of minutes, and we're going to take it from there. All right. So, by any chance, anybody has the answer for us? Anybody has worked it out? All right. Let's look at what happens next. First and foremost, let's draw the diagram so we see what's happening. Okay. So 880 feet across. Okay. You have those angles, 69.2, 65.5. So obviously we have all the angles because we can add up those two subtracted from 180. So that shouldn't be a big deal, right? So add them up. They must be 180, so the missing one can be found easily. Now, since we have all the angles and one side is 880, we can find all the sides. Okay. So we can find one of the sides, that is x. Okay. So we can say sine of 65.5 over x is the same as sine of 45.3 over 880. And we use that because 880 is known, okay, class? Because 880 is known. And so with that being the case, cross product will give us x. So what is x? 880 times sine of 65.5 divided by sine of 45.3 gives us the answer. It's an easy calculation, class. Cross product will do the job. Everybody knows that. Therefore, we have x. And now that we have x, what do? Well, we can look at one of the triangles and we say, if we are looking at, let me just maybe, we are looking at this one. Okay. We can calculate the height using the fact that the sine of 69.2 is the opposite, which is h, over the hypotenuse, which is x, and we just found it to be 1126.57. By the way, this is not the only way. This is the fastest way. Okay. Now cross product will do the job. So h is 1126.57 times sine of 69.2, and with a bunch of decimals. It's a good practice to write it with a bunch of decimals, and we get the height. Sounds good? Everybody okay with that? Is there any questions so far? Okay, just do me a favor, let me know if by any chance we are going too fast for anyone. Okay, so you want to let me know, and then we slow down. Okay, so I want to move on. I assume everybody is okay with this stuff. Okay, all right, here's what comes next. So this is the last question. Again, if somebody be kind enough to read the question for us, I really appreciate it. Go ahead and do that.
The navigator of a ship at sea spots two lighthouses that she knows to be 3 miles apart along a straight seashore. She determines that the angles formed between two line-of-sight observations of the lighthouses and the lines from the ship directly to shore are 15 degrees and 35 degrees. A, how far is the ship from lighthouse P? B, how far is the ship from lighthouse Q? C, how far is the ship from the shore?
Thank you so much. Again, I appreciate that. So again, let's just quickly see what the drawing is giving us. Okay, is this. Okay, so we have 15. We have 35 there. Okay. And we have the 3 miles. So let's see what we need to do. So okay, let's do sine 50 divided by 3. Okay. Equal sine 55 divided by PR. We find PR, okay, to be 3.21 miles. Sine 75 over QR, 3.78. Okay, before we go there, okay, maybe, I just want to make sure everybody understands what happens here. Okay, maybe I should have explained that. Class, everybody can see the 15 and 35. My apologies, I thought, it was clear, but everybody can see 15 and 35. So let's look at, let me use a different color here. Let's look at this one. Okay. the top half. So everybody can see we can calculate this angle, if you want to call it P, okay? And of course, angle R, first and foremost, angle R, okay, maybe I should, angle R is the sum of these two numbers, right? Everybody can see that one adds up to 15 plus 35 equals 50 degrees, right? So those add up to 50 degrees. The next thing I want you to notice is that if this is 15 degrees, then this angle is 90 minus 15 degrees. Everybody understands what I'm saying here, right? And let me use a different color. And this angle is what? It's just 90 minus 35 degrees. I hope everybody can see why. Because the top half is a right triangle, the bottom half is a right triangle. All angles add up to 180. We have a 90-degree angle, we have a 15-degree angle, we can find the P angle. We have a 90-degree angle here, down here. We have a 90-degree angle, we have a 35-degree angle, we can find the Q angle. So that's why this is 90 minus 35, okay, or 55 degrees. Angle R was 15 and 35. And angle P was 90 minus 15 or 75 degrees. So that's the first thing that I want to make sure is clear to everybody, okay? Does that make sense, everybody? So we have the P, the Q, and the R angle. So that's the first thing that we should be comfortable with. Now, the rest is really a piece of cake. You have the sine law to use because you have one side and all the angles you can find all the sides. It's really not a big deal, okay? So with that being the case, for example, sine of 50, because R is known to be 50, the angle R, and opposite that is known to be 3 mod, so we use that. And then if you go with Q, that would be sine of 55 degrees. Okay, so this is in essence sine of Q, okay, everybody? And this is sine of R, okay? Does that make sense? Sine of R, sine of Q. And cross product will find PR, the distance between P and R is 3.21 miles, okay? All right, sine of 50 over 3, again, this is sine R, remember that? This is sine R cross. And 75, this is sine of P. And cross product will do the job here too, yes? And you find QR to be 3 times sine 75 over sine 50, and that gives us 3.78. There are a number of ways you can find part C. Everybody's okay with A and B, therefore, right? To find part C, you want the distance D. You can use, I don't know, sine of 55 degrees, for example, is D over QR, or sine of 75 degrees, okay, is the distance over PR, or you can use the sine law on that as follows. There are really, this is not the only way. There are many, many, many different ways to do that, everybody, okay? So what we are in essence using, look at the very top right triangle, okay, the top one. You can use a sine law on the top one, okay? So this is the top one, class. Use a different color. This is the top one. Let me use actually the color that, if you use the top one, just this one, class, see the top one. Okay. Now sine of 90, okay, sine of 90 over PR, okay, so this is PR, and then sine of 75 over the distance that we are looking for. Cross product will give us the answer. Is this the only way? No. Okay. Just as an example, using the green triangle, if you were to use, let me use a green color. So, and again, at this one, you have so many ways to do that. If you were to use this one, for example, you could say sine of 55 degrees is the opposite, which is the distance D, over the hypotenuse, which is the distance what? QR. Okay, and remember, QR is really known. Sine 55 is known. So multiply the two and gives you the distance. That may even be faster. But for the sake of a section, we were using sine law here. All right, I want to spend a few minutes on the next section. At least we get that started. And then we take it from there when we come back on Tuesday. So I'm going to assume we are okay and done with this. Is there any questions? Everybody clear? I want to go to the next section, class. All right. Everybody can see section 8.3, the law of cosine.
Yeah.
All right, so excellent. So let's quickly recap what we did, and then we move on to this section and spend some time on that. So let me hide this. So we are looking at the law of cosines, and remember, one of the things we can do is SAS, side, angle, side. Side, angle, side, that means included angle, and SSS, all sides are given. So again, I keep on giving you this page. I can't emphasize the importance of this page, class, okay? Now I have the sine law here, and I've also added the cosine law, okay? The cosine law says a squared equals b squared plus c squared minus 2bc cosine a, okay? And if you solve for cosine a, you can find b squared plus c squared minus a squared over 2bc. You really don't have to memorize that. The first one is good enough. But let's see if we can go through that and spend some time at the very least getting to the proof of that. So this is another page that you should be comfortable with, class. Okay. Angle of elevation and depression was discussed. So let's put that in slide mode. And let's see what's going on here. When we have sine law in combination with cosine law, we can solve every type of a triangle. One case is called SAS, if you will, two sides and the included angle. That gives you a unique solution and you're done. Or you have three sides. Remember, the three sides also gives you an answer. unless one side is larger or equal than the sum of the other two sides. It doesn't work, it fails. So what you're looking at, those are called law of cosines, okay? And if you look at, for example, the last one, okay? If you look at the last one, okay? And you move minus 2bc to the other side and a squared this way, then it gives you this, right? Cosine becomes the right side divided by 2bc. In other words, if the angle is missing and all sides are given, we can find cosine of it as b squared plus c squared minus a squared over 2bc. Now, before we look at the proof, I want to tell you something, and I don't know if you've heard that or if you know it, but has anybody heard that Pythagorean theorem is a special case of the cosine law? How many people have heard that? Anybody has heard that? Pythagorean theorem is a special case of a cosine law. Think about it. Why is that? If the angle is 90 degrees, let's just look at one of them. For example, let's look at the first one, class. Look at the first one. What if capital C is 90 degrees or pi over 2? What happens? Class, what is cosine of 90 degrees? Anyone? Cosine of 90 degrees equals?
0.
Very good. So if C is 90 degrees, and we know cosine of 90 degrees is 0, this will change to 0, and this is your Pythagorean identity. So Pythagorean identity or theorem is a special case of a what? Cosine law. Cosine law. That sounds good, everybody? All right, let's quickly look at the proof of that. Again, you're not responsible for that, but if you can follow it, you're in good shape. Let's look at the proof of cosine law. Okay. We have ABC, the big triangle. We drop a perpendicular. We call it H. And now it gives us two triangles that are both right triangles. Okay. So starting with ADC, okay. We can write a couple of things. We can write Pythagorean theorem, okay. Pythagorean theorem is the smaller sides or the legs. So this side AD, we say it's x. So x squared plus h squared is b squared, right? Also, cosine A is the adjacent, which is x, over the hypotenuse, which is b. And we can do the cross product. X becomes b cosine A. So that's dealing with the left side. Let's look at the right side, everybody. Let's look at this triangle. This is also a right triangle. Everybody agrees with that. We want to write Pythagorean identity for that. So we can see that, let's write it up here. We can see that BD squared plus CD squared equals BC squared, right? So BD squared plus CD squared equals BC squared. Now, what is BD? BD is C minus X. What is CD? H. What is BC? A. So this is the formula. I hope everybody is following that. We are going to expand that. So the parentheses squared is C squared minus 2CX plus X squared plus H squared equals A squared. I hope everybody can see this, okay? This one is the same as this one, right? All right. Now, what else can we see? Okay, let me erase that because I want to show you something. We are going to use this stuff. We are going to use everything that we see here. X squared plus H squared is the same as B squared. And then X is B cosine A. So take a look. These two can be replaced by B squared. And then X can be replaced by B cosine A. So let's do that. So C squared minus 2C, instead of X, we're going to put B cosine A. And then instead of X squared plus H squared, we're going to put B squared. All you have to do, just rewrite this as A squared equals to the left side in this order. And this is the proof for the cosine law. And I'm going to repeat, so I hope everybody is comfortable with that and everybody is following that. So what is cosine law? Cosine law is a special case of a Pythagorean theorem. Let's quickly look at one example and we call it a night. So this was the proof. Here's an example of that. So we are given the following class. A is given as 2. Okay. B is given as 3. Okay. So A is 2. B is given as 3. And capital C is 60 degrees. So this must be capital C because A and B. And C is in between. Okay, class? All right. So we have the formula here, A squared equals B squared plus C squared minus 2BC cosine A. And so we're going to plug in. Okay. Now please understand, class, A squared equals B squared plus C squared minus 2BC cosine A, or C squared equals A squared plus B squared minus 2AB cosine C. What you need to remember, if it's helpful, you see this one goes together with this one. And then these are other variables. Okay. As long as you know one of them, I think the other ones shouldn't be too bad. So C squared is equal to A squared plus B squared minus 2AB cosine C. Now, 60 degrees happen to be a common arc, so we know it's 1/2. So that's actually a very easy calculation. Normally, we have to use what do you call it? We have to use a calculator. This is a common arc. We have nothing to worry about. So what is C is the same thing, take a root. So we have all the sides. So the next thing is to find all the angles. All you need is one more angle. Now, at this point, class, you can use any of them you want. Remember, you have now all the sides. I want to make sure everybody understands what's going on. Okay, C is given. So if you want to use the sine law, you can. But for the sake of the section here, let's continue with the cosine law and look at cosine A, which is B squared plus C squared minus A squared over 2BC. I'm looking at this formula, okay? And plug in. It's a simple calculation. Gives you 12 over 6 squared of 7. You drop the 6, you get 2 over square root of 7. Okay, so this one, class, is 2 over square root of 7. And this, if you multiply by square root of 7 over 7, gives you 2 square root of 7 over 7. It's really not that big of a deal. You can even approximate it with a number, but just because the, C was easy to find and cosine was known, then we can keep it as precise. It's not that big of a deal. So what is A? A is the cosine inverse of this number, which is 40. So 40.9 degrees. And now that you have this, you have one of them to be 60 degrees, one of them to be 40.9 degrees, and the last one is 180 minus the sum of the two. And so all angles are known. Sounds good, everybody? Any questions? That's it for tonight. I'm going to pause the recording and talk to you for a couple of minutes.